विद्यार्थी मित्रांनो, मागल्या काही पिरियड पासून आपण ओहम्स लॉ बद्दल चर्चा करत राहिलो. ओहम्स लॉ काय सांगतो? तर as far as the physical state of the conductor remains same, the current flowing through the conductor is directly proportional to potential difference across the ends of the conductor. हे सांगत राहिलो आपण. Current directly proportional to potential difference, याचाच अर्थ potential difference is directly proportional to the current. Therefore, the potential difference V, sometimes we call it as a voltage. V is equal to I into R, where R is the constant of proportionality. It is the resistance of the given conductor. The resistance of a given conductor is given by R is equal to V divided by I. With increase in resistance, there is a decrease of current and vice versa. अशी डिव्हाइसेस जी ओहम्स लॉ पूर्णपणे ओबे करतात त्यांना आपण ओहमिक रेजिस्टन्सेस असं म्हणत असतो. ओहमिक डिव्हाइसेस. Metals are the good conductor of electricity. They are ohmic. Ohmic devices are the devices which obeys Ohm's law completely. And if a graph is plotted between the two variables, one is the potential difference voltage V and the current I, then the nature of a graph is a straight line. Therefore, it shows that the relation is linear. The relation is linear, and if you take a slope of the graph between any 2 points, the slope of the graph will be here delta V divided by delta I, and it is equal to the resistance of the conductor. Slope of the graph here, what, let A and B are the 2 points on the graph. C is the point of intersection of the perpendiculars drawn from A and B. Then this slope of the graph is nothing but it is equal to y2 minus y1, that is BC, divided by x2 minus x1, that is AC. BC is the change of potential difference and AC is the change of current, and it will be constant throughout the straight line. Such a types of the devices in which the graph of V against I is a straight line are called as the ohmic devices, in which the graph is linear and a straight line. There are some devices such as liquid electrolytes, semiconductor devices, vacuum tubes, in which Ohm's law is not obeyed at all. Such devices are called as non-ohmic devices. In non-ohmic devices, if you plot a graph between a potential difference voltage and a current, nature of graph will not be a straight line, it will be a curve. And slope of the graph at every point will be the different. If you take the slope of the graph at point P, then it will give the resistance delta V2 divided by delta V1, delta V2 divided by delta I1. This will be the resistance at point P, means it shows that the resistance varies from point to point, because a resistance at point Q is different. It is R1. R1 is equal to delta V1 upon delta I1. Delta V1 upon delta I1, this value at Q and this value of resistance at P will be the different. And therefore, in non-ohmic resistances or devices, the relation between the potential difference and current is not linear, it is non-linear. relation, and the graph is not a straight line, it a curve. Therefore, the resistance is not constant throughout the graph, because slope throughout the graph will not be the same. And therefore, in non-ohmic resistances, we have to calculate the instantaneous value of the resistance, the value of resistance at a given instant of time, for which delta t is very small. That is, for the given instant of time, in a very short interval of a time, the change of potential difference to change of current will give a resistance for that instant, and it may be the different at the different instant of time. Such devices are called as non-ohmic devices because they do not obey Ohm's law. मित्रांनो, आपण मागे काय सांगत गेलो की एखाद्या कंडक्टरच्या अक्रॉस जर आपण बॅटरी किंवा सेल लावला तर त्या कंडक्टरच्या अक्रॉस इलेक्ट्रिक फील्ड तयार होते आणि ती इलेक्ट्रिक फील्ड कंडक्टरमध्ये असलेल्या इलेक्ट्रॉन्सला निगेटिव्ह टू पॉझिटिव्ह डायरेक्शन मध्ये, इलेक्ट्रिक फील्डच्या निगेटिव्ह टू पॉझिटिव्ह डायरेक्शन मध्ये अलाइन करते आणि त्यांना तसं मूव्ह करायला भाग पाडते. आणि मग त्या इलेक्ट्रॉनच्या मोशनमुळे इलेक्ट्रॉनिक करंट निगेटिव्ह टू पॉझिटिव्ह आणि कन्व्हेन्शनल करंट पॉझिटिव्ह टू निगेटिव्ह होतो, ही गोष्ट आपल्याला माहिती आहे. त्याच्यावरून ओहम्स लॉ सुद्धा माहिती आहे आपल्याला की कंडक्टरच्या अक्रॉस आपण बॅटरी लावल्यामुळे बॅटरीचं पॉझिटिव्ह कंडक्टरच्या ज्या टोकाला असतं ते हायर पॉझिटिव्ह पोटेन्शियलला आहे आणि निगेटिव्ह ज्या टोकाला आहे ते लोअर पोटेन्शियलला आहे. त्या दोघांच्या मध्ये पोटेन्शियल डिफरन्स तयार होतो आणि तो पोटेन्शियल डिफरन्स आणि त्याच्यामुळे होणारी इलेक्ट्रिक फील्ड करंटच्या वाहण्याला कारणीभूत आहे. Therefore, current flowing through the conductor is directly proportional to the potential difference across the ends of the conductor. This is Ohm's law. याच्या थोडंसं पुढे जायचं आहे आपल्याला. आपण इलेक्ट्रिसिटी मधलं अतिशय बेसिक असं एक सर्किट बोर्डावर काढलेलं आहे. दिस इज द बेसिक फंडामेंटल इलेक्ट्रिकल सर्किट in which, as I had drawn here two cells, I will call it as a battery. If it is only a single cell, I might have been saying that a cell. Let a battery is connected across the ends of a resistor which is having a resistance of R. आता इथं परत एकदा आपण गडबड नाही करायची बरं का, कसलीच गडबड नाही करायची. रेजिस्टन्स ही प्रॉपर्टी आहे आणि ती फिजिकल क्वांटिटी आहे, मेजरेबल आहे, ती ओहम मध्ये मोजायची आहे. आणि रेजिस्टर हा रेजिस्टन्स प्रॉपर्टी असलेला डिव्हाइस आहे. आणि रेजिस्टन्स ही प्रॉपर्टी असलेला डिव्हाइस रेजिस्टर सर्किट मध्ये दाखवण्याचं हा सिंबॉल आहे, झिगझॅग. Let us consider a resistor of a resistance capital R is connected to a cell of which EMF is E. Now let us consider the end A of the resistor is connected to the positive of a battery and end B is connected to a negative of a battery with the help of a conducting wire. सुरुवातीलाच एक गोष्ट अशी क्लिअर करून टाकूया की कंडक्टिंग वायर्स हॅव अ व्हेरी निग्लिजिबल रेजिस्टन्स. Though they have, we are going to neglect it. Therefore, whatever is the positive potential is at the positive of a battery is same as at point A, and what is the potential at negative is same as that of B. Therefore, though there is no potential difference between these 2 points, the negative terminal and B, there is no potential difference. They are at the same potential, but still there is a flow of current. Let the current flowing through the circuit is I. The current flowing through the resistor is I, and the current flowing throughout the circuit is I. आता बघा इथे ईचा पॉझिटिव्ह आणि ए सारख्या पोटेन्शियलला आहे, कारण याच्यामध्ये कसलाही रेजिस्टन्स नाही असला तरी तो निग्लिजिबल आहे, इथे पण रेजिस्टन्स असला तरी निग्लिजिबल आहे. मग या दोघांमध्ये पोटेन्शियल डिफरन्स नाही, पण तरी करंट वाहतो. करंट व्हायला पोटेन्शियल डिफरन्स असायला पाहिजे, तो आहे. ए आणि बी मध्ये पोटेन्शियल डिफरन्स आहे. A is at higher positive potential, B is at lower positive negative potential or at lower potential. Therefore, there is a flow of current from A to B. The potential at A is greater than potential at B. The potential difference between A and B, VA minus VB, let it is represented by V. V is the potential difference. Sometimes we call it as a voltage. Now, again, we will go a little bit back. In a conductor, there are large number of free electrons. They are in a state of random motion. When battery or a cell is connected across the ends of the conductor, electric field is developed, and the electric field applies force on the electron so that electron tends to move towards the positive potential or towards the positive terminal of the battery. And when it begins to move towards the positive terminal of the battery, at that time they used to collide with the positive ion cores. During that collision, the electron loses energy and ion core absorbs energy, kinetic energy. Because of energy absorbed by the ion core, they begin to vibrate with more velocity. And because of that increase in the kinetic energy of the ion cores, the temperature of that conductor increases, and this is why the conductor get heated whenever current passes through it. Let Q be the charge flowing through a resistance from A to B. In a very small time delta t, let Q be the total charge that flows from A to B in a very small time delta t. Then obviously I will write what current is. It is the rate for flow of charge. Therefore, I is equal to Q divided by delta t. What potential difference is? Potential difference is the amount of work done in order to move a unit positive charge from one end to the another end. Potential difference between any 2 points in a conductor or in an electric field is defined as amount of work done in order to displace unit positive charge from one point to another point, from higher potential to lower potential. Potential difference ची व्याख्या काय सांगते? It is work done for unit charge. If Q is the work done to displace a charge If W is the work done to displace a charge Q, then work done for unit charge is W by Q. Therefore, work done in this case is potential difference into charge. Therefore, a work done in order to displace a charge from A to B is W, and it is equal to potential difference into charge. करंट म्हणजे काय? फ्लो ऑफ चार्ज. किती चार्ज गृहीत धरला? क्यू चार्ज गृहीत धरला. कुठून कुठे गेला? ए पासून बी पर्यंत गेला, कंडक्टर मधून गेला. क्यू चार्ज ए टू बी गेला, तर त्या काळामध्ये त्याच्यावर झालेलं वर्क किती असेल? W इज इक्वल टू व्ही क्यू. हे वर्क, दिस वर्क decreases the potential from A to B. Why there is a potential difference? Because whatever is the energy supplied by the cell or a battery is used to perform a work, and whenever work is done, there will be decrease of potential energy, and therefore potential energy decreases whenever charge Q flows from A to B. Therefore, decrease of potential energy, I will write it as delta U. It's a decrease of potential energy. This decrease of potential energy is the amount of work done. This amount of work done is equal to potential difference between the 2 points and the amount of charge flowing through it. And amount of charge flowing through it, Q is equal to, I will write it as I into delta T. Therefore, decrease of potential difference, decrease of potential energy whenever charge flows from A to B, delta U is equal to V into I into delta T. Therefore, this much amount of work is done whenever current I flows through a conductor in time delta T, and when it has a potential difference of V. And to perform this work, the energy is spent by a cell or a battery connected to a simple electrical circuit. Work done per unit time or energy spent per unit time is called as the power. Therefore, power dissipated. Power dissipated is the energy spent per unit time. It is delta U divided by delta T, or it is work upon time. It is equal to V into I. This is the amount of power dissipated, which is given by V into I. It's a simple product of potential difference and the current. सोपं इलेक्ट्रॉनची मोशन सुरू झाल्यावर त्या ॲटम बरोबर कोलाइड होतात, एनर्जी लूज करतात, ॲटम्स एनर्जी गेन करतात, त्याच्यामुळे त्याची कायनेटिक एनर्जी वाढते. ती वाढलेली एनर्जी हीटच्या फॉर्ममध्ये येते रेझिस्टन्समध्ये, म्हणून रेझिस्टन्स तापतो. मग ही एनर्जी देतं कोण? तर सेल किंवा बॅटरी देतं. मग क्यू चार्ज वाहून जाण्यासाठी किती वर्क होतं? तर व्ही इंटू आय इंटू डेल्टा टी. वर्क डन पर युनिट टाइम म्हणजे पॉवर आहे, तर किती पॉवर डिसिपिएट होते? तर व्ही इंटू आय इतकी पॉवर डिसिपिएट होते. Therefore, at the end, what you have to remember is that the work done in an electrical circuit is equal to V into Q, or I will write it as V into I into delta T. I delta T is the charge. Delta T is the time for which current flows through the conductor. And what power is? Power dissipated is the work upon time. It is equal to V into I. But actually I is V by R. Therefore, it should be equal to V square by R, or I will write the same power in different form as P power is equal to, if V, I can write it as I into R into I will write it as I square R. Therefore, power can be represented in different way, that is V into I, it is V square divided by R, or it is I square R. This is the power dissipated. आता रेझिस्टन्स मध्ये ही डिसिपेट झालेली पॉवर, वापरात आलेली एनर्जी कशाच्या फॉर्म मध्ये येते? हीट एनर्जीच्या फॉर्म मध्ये येते. एनर्जी कॅन नायदर बी क्रिएटेड नॉट इट कॅन बी डिस्ट्रॉयड. देअरफॉर डिक्रीज ऑफ पोटेन्शियल एनर्जी इन्क्रीजेस द हीट एनर्जी. हे रेझिस्टन्स मध्ये. इलेक्ट्रिक मोटर मध्ये दिस डिक्रीज ऑफ एनर्जी utilized as a mechanical energy to run the motor, and in rechargeable batteries this energy spent by a cell is energy gained by the rechargeable batteries, and like that there is a transfer of energy with flow of current. This is very beautiful concept which explain how power is dissipated in an electrical circuit. आपण आताच खूप छोट्या छोट्या गोष्टी सांगितल्या. काय? करंट म्हणजे काय? फ्लो ऑफ चार्जेस. चार्जेसला एकाच दिशेत मोशन मध्ये आणण्यासाठी वर्क करावं लागेल. हे वर्क केल्यावर एनर्जी कमी होणार आहे. ती कमी पडलेली एनर्जी किंवा वर्क करण्यासाठी एनर्जी देण्याचं काम कोण करतं? बॅटरी करते. बॅटरी प्रोव्हाइड्स सफिशियंट इलेक्ट्रिकल एनर्जी इन ऑर्डर टू परफॉर्म वर्क so that the electron flows from higher potential to lower potential. This is the signature statement of this video lecture. Now, to our household devices, the electrical energy needed to run the household devices is supplied by the government, and we used to pay the bill for using that electrical energy. What I had said, the electrical energy is the amount of work done. This amount of work done, what it is equal to? V into Q. It is equal to V into I into delta T. Q is equal to I delta T. The potential difference into the current flowing through the device into time for which the current flows through the device, that much is the amount of work done in order to make the current flow through the device. This work done is due to the energy supplied. Therefore, the energy consumed is equal to, I will write, energy consumed by any device is equal to V into I into delta T. This is energy consumed. Let us consider a current of 6 ampere flows through a device with a potential difference of 230 volt, and the device runs for a time of 5 hours. आपण उदाहरण म्हणून असं एक गृहीत धरूया की एक इलेक्ट्रिकल डिव्हाइस आहे. आपल्याला MSABने म्हणजे आपल्या गव्हर्नमेंटनी सप्लाय केलेलं पोटेन्शियल डिफरन्स किती आहे? 230 व्होल्ट इतका आहे. डिव्हाइस मधून कॉन्स्टंट करंट फ्लो होतो 6 एम्पियर. तो जेव्हा रन करतो तेव्हा, ॲज अन एक्झाम्पल, फ्रीज और ओव्हन और युअर वॉशिंग मशीन. In that case, how much is the energy consumed by the device. That we can determine. Energy consumed by the device, it is equal to 230 volt into the current 6 ampere into 5 hours. 5 hours means 5 hour, 5 into 60. That is in minute into 60. This is hour converted into minute and minute converted into second. This will be equal to 230 into 6 into 5 into 3600 is equal to the value that we will calculate. Value that we are going to calculate is nothing but in joules, and this much energy is consumed by the consumer to run that electrical device. एवढी एनर्जी त्या इलेक्ट्रिकल डिव्हाइस वापरणाऱ्या कंझ्युमरने कंझ्युम केलेली आहे. मग जे इलेक्ट्रिसिटी बोर्ड आहे ते इलेक्ट्रिसिटी बोर्ड या कंझ्युम केलेल्या एनर्जीवर तुम्हाला बिल आकारत असतं. द इलेक्ट्रिसिटी बोर्ड युज्ड टू अप्लाय the consumption bill on you as you are using the electrical power and electrical energy, but in that case the thing is different. What different the thing is? Here the electrical energy is measured in kilowatt hour. This is equal to the 1 unit of electricity board. 1 unit of electricity board is kilowatt hour. 1 kilowatt hour is equal to 1 unit. Here we have determined it in joule and we have to find out in kilowatt hour. And in kilowatt hour, how much is the energy consumed, that we will see. Now, here the energy consumed, U equal to, it is equal to 230 into 6. That is equal to 230 into 6. That is into 5. That is 606, 6 3s are 18, 6 2 the 12 plus 1 13. That is 1380 watt into 5. And it should be equal to 1.38 into 5 kilowatt hour, and it will be watt hour. And it comes out to be equal to 6.9 kilowatt hour, and it is nothing but 6.9 units of electricity board. Your meter will show increase of the units by 6.9 if you run an device for 5 hours and the device used to take 6 ampere of current to run for a specific reason, and for 6.9 unit, whatever is the rate decided in Maharashtra, it is about 10 rupees per unit. At that time you have to pay 69 rupees for this consumption of electricity. This is how to determine the amount of energy consumed and what is the power dissipated by the electrical devices. Thank you very much. I hope you might have been understanding all these things. We will meet in the next video lecture. Please subscribe the channel and go through all the video lectures one by one to get adequate knowledge of this current electricity. Thank you once again.